Welcome to the second day of Container Days. And it's good that you're still with us and not preferring the air-conditioned office or data center, maybe. It's warm in the audience, I suppose. But I didn't expect that. It's still warmer here on stage because we have spotlights. So bear with us if we are sweating. So, ServiceMesh, it will not take care of the heat. I can say that already. ServiceMesh loves legacy, likes legacy, ServiceMesh and legacy. We were not sure about the title in the beginning. Maybe ServiceMesh hates legacy. We will see that in the proceedings of the talk. What we would like to show is the benefits of using a service mesh in a container platform, especially in the context of having legacy, say, host-based applications as well. Because that's our daily business so far. We started our journey with Kubernetes approximately 2 years ago. And of course, we still have a bunch of host-based systems. And we see that in the proceedings of the talk, how we take care of that. So who are we? My name is Stephan Fudeus. My official title is being an expert for container platforms, whatever that means. I'm 16 years now in the professional IT. I take mostly care of distributed systems. I used to start with one-on-one hosting in 2005 and took care there of distributed systems. The one-on-one My Website product was one of my babies. What I took to scaling from 150,000 users to 1 million users and theoretically linearly scaling. That's resolved now to a newer product. Since 2017, I joined the one-on-one mail and media. That's a different branch of the one-on-one. And there, my current role is being the product owner for our internal Kubernetes cluster. So it's not a public offering. It's just the internal platform where we intend to run nearly all our stuff on. And besides being the product owner, getting to say what we want to do there, I'm the technology lead for Kubernetes and mail and media. So I get to say how we want to do that there. And I may put my hands on the clusters as well, so I get to do the things as well. That's a good thing. And if you would like to follow me on Twitter, you can find my handle there. It's not so much original content from my side. It's mostly retweets in the Kubernetes and container area.
Okay, I'm David Miedemarueli. I'm an architect for automation, which includes Kubernetes, but a lot of other stuff we'll see in a minute. I'm in a professional IT business since 15 years. In 2007, I switched to one-on-one hosting, started as a system administrator, became an architect later. And essentially, that's what I'm still doing, but since 2015 with one-on-one mail and media. Although one-on-one probably needs not much of an introduction, there's a quick overview whom we are working for. The mother company is United Internet, essentially an internet specialist, mainly active in Europe, but also in the United States and worldwide with some of the products. We have currently more than 9,000 employees worldwide, approaching 100,000 servers in 10 data centers, also distributed worldwide, centered in Europe and the US. And there's two main business lines. It's access, you probably know that, mobile phones, DSL, landline, stuff like that. And there's applications, which is covering sort of all the rest. First of all, this is Ionos, which is bundling the entire web hosting and web services business. So we are seeing ourselves as a partner for small and medium-sized business and all their digital needs. But there's products for sort of all levels of utilization, from your personal web space to whatever your company in a larger scale needs, cloud applications and infrastructure as a service. That makes Ionos the largest web hosting company in Europe, with currently more than 8 million contracts and more than 12 million domains hosted. If you want to know more, in particular about the cloud computing products, don't forget to visit the booth over there. The colleagues are happily looking forward to talking to you. One-on-one mail and media, you just heard that we currently work for that branch of the company. This is the business unit dealing with emails and some cloud applications. Main brands are WebBE, GMX, and Mail.com. So it's all centered around the email business. We have mostly free services, but also paid and then enhanced services. Currently, there's about 33 million active users every month. Okay, so how do we get all these applications we need for running that business online? That's how architects see the world. It's always simple. But to give you an idea of the environment which we are talking about, and this is mainly what we do at Mail and Media. So starting from a product idea, developers convert that into code, which is hosted in a GitLab instance. We have a Jenkins or GitLab CI in the meantime for building binaries from the applications, in particular also Docker images. All the binary packages and Docker images are hosted in an Artifactory from where they are picked up with a CI/CD tool, GoCD, and this handles the deployment chain from development stage over integration up to the live and production stages, including running testing frameworks and all that stuff. Under the hood, we are using Ansible, and from there we are branching out, either deploying directly to hosts or invoking Helm template in particular to install stuff into Kubernetes. We also automatically configure the load balancing stuff so that services get automatically exposed and available to our users and customers. Currently, there's about 1,000 services being run in Mail and Media. 90% of them still running on bare metal or virtual machines. Currently, we have about 10% of them being run on Kubernetes. So there's two worlds that need to be connected. The Kubernetes world and the legacy. And with 1,000 services, you can probably imagine the dependency meshes getting quite messy. In particular, there's a complication that not all of the applications we have built in the past are already cloud native or cloud ready. So many of them still are not stateless. Some still try to log on local disks. Some use IP-based ACLs instead of proper authentication, stuff like that. And to be honest, some of them will never arrive in the cloud-native world. So we need to connect these worlds nevertheless. And this is how we do it.
So, and as originally said, we introduced Kubernetes about 2 years ago, started with a kickoff workshop and the concept and how we do things, and we took help from outsiders, namely Innovex in our case, to support us with building our platform, and it took about half a year until we had the first production application running in our clusters. So, but why do we choose Kubernetes? What's our container strategy? Why do we do that? And Kubernetes was already kind of a hype at that point in time, and Kubernetes is a great centrally provided platform. We intended to have fast development cycles. That's the main goal we want to achieve. The software development teams should be able to work on their own pace, and if they have something ready, which is quite often, they should be able to roll that stuff out. But of course, we had security in mind, so we are basing our clusters on soft multi-tenancies. We have friendly users because it's just internal usage, so soft multi-tenancy is sufficient. But still, we want to separate them from each other. On a quota perspective, nobody may just consume masses of the cluster without us knowing. And of course, if some user breaks his part of the cluster, the remaining part of the cluster for the other tenants shall not be broken. And of course, we have a strategic focus on microservices, not necessarily just Java-based Spring Boot services, but that's our majority. But services tend to get smaller. They have a smaller scope to take care of. That's easier to oversee. So if you just lose one screw on the one end, not on the other, and some cog drops off. That's our idea about microservices. And we have multiple clusters running. It's about 15 clusters so far, and we do that because we separate on a network layer between front-end clusters and back-end clusters, and only the front-end clusters are internet connected, obviously. We have 3 data centers in which we run our clusters, and so we split there. We have no federation or merged Kubernetes control plane across multiple data centers. Each data center has its own clusters, and applications which shall be highly available or geo-redundant are just deployed by their operations team in multiple clusters. And the third dimension on which we split is live versus non-live, obviously, and that gets us to 15 clusters so far. We just use bare metal. We have no virtualization step in between. Nevertheless, for the future, we might go into KubeVirt, for example, to run virtualized payload within the Kubernetes clusters. But Kubernetes itself will not run on VMs, at least for our environment. Another interesting thing, especially for ServiceMesh, is our network topology. As you know, when knowing Kubernetes, there's host networks, there's pod networks, and there's service networks. And our pod and service networks are in the RFC 6598 space, the CG NUT space. It's all the 100.64/10. And that's not routable outside of the Kubernetes clusters. Of course, we could make it routable within our data centers, but that's not the idea. The clusters are isolated completely. They have their network space, and everything which leaves the cluster gets a standard IP address from the RFC 1918 space. In our case, usually 10/8. And that's an important thing, as we will see, for service meshes. So why service mesh at all? We have quite a service mess of microservices. When you go into smaller and smaller services, you get more services, and that's just messy to get an oversight on that. And we require quite some standard functionality. We want to have telemetry data out of our services. We want to be able to fine-grainedly route our requests. We want to do canary releases. We want to do A/B deployments, blue-green deployments, whatever. You name it, we want to have it. No, not everything, but we want to have the core benefits you need for deploying microservices. Circuit breaking is an important thing. Of course, you can do that with libraries and code, but everybody needs to do that. Every application development team needs to integrate the libraries. If you have multiple languages, you need to have different libraries. Are they properly interoperable? Most likely not 100%. We want to do rate limiting, which needs to be otherwise done in the application. And the most important thing as well, security. We want to have TLS between our pods as well. We already have, of course, TLS for every connection from outside of the cluster to inside of the cluster, and we can terminate on Ingress controller, for example, or the applications themselves can terminate their TLS connections. But we as well want to have full security within the clusters. Authentication, authorization, of course, is an additional topic there as well. Everything shall be declaratively configurable, so we don't want to build that into the code. Ideally, we can just add some configuration and say, okay, now it's like that. Being able to be centrally maintained is a plus, especially because our Kubernetes clusters are centrally provided by one dedicated team. And I already mentioned that one. Service meshes are language agnostic. It doesn't matter if you use Node.js or PHP or Java or Go. You can always just use the same infrastructure. So, and we chose Istio as a first go. Spoiler, there will be a slide with different service mesh implementations and what we did with them. But Istio was our first choice to start with the prototype. So how do things look in Istio? Or in service mesh in general? That's in-mesh communication. You have some client within your mesh, and you have a pod, which is a target service, and maybe you even have another destination service. And the main point in the service mesh is that every application, we see that in the pod with service A, the application gets a sidecar proxy, and every traffic runs through the proxy. Inbound traffic gets through the proxy, and the outbound traffic leaving the service goes through the proxy as well. And so between two proxies, the TLS connection, for example, can be established, and the proxies, when configured properly by the ServiceMesh control plane, that exactly knows, oh, that was the client, and that's the service, and I can terminate that, I can authenticate that, I know that it's true, and I know who that is, so I know if I can allow that connection or not. That's the in-mesh perspective. But what about out of mesh? The title of the talk was including legacy host-based systems. We, of course, still have that, and we will, even when we are done with our migration, whatever done means. But we have hosts outside of the Kubernetes clusters for services which never will make it into the clusters. And Istio provides a way with ingress gateways and egress gateways. So even if you have clients and destinations outside of your mesh, they can communicate with an ingress gateway, which has the initial proxy, and from that the Istio mechanisms kick off for the traffic within the mesh. And if traffic wants to leave the cluster or it wants to leave the mesh, it can go through an egress gateway for additional properties, like the egress gateway has a special IP address, and only that is allowed in your firewall to exit to some other point outside of Kubernetes. But you can reach from your in-mesh pod outside destinations as well that you can configure.
Okay, this is pretty cool, but we want to go further even. Wouldn't it be very cool to have all these nice features that a service mesh provides also for your host-based services? Yes, definitely. And it would fix a lot of things that are currently not ideal or plainly broken. So the magic word is mesh expansion. And we've been playing around with that based on Istio 1.0 series. That's important because Istio 1.0, as we'll show, has not everything that we want to have and need. So essentially, you can install the Istio proxy on a simple host and then connect it to the service mesh and the control plane that is running inside the Kubernetes cluster. One of the main benefits that comes sort of out of the box is that it runs MTLS, so mutually authenticated TLS, between sort of legacy host-based services and the Kubernetes world. And all this is uniformly, declaratively configured in Kubernetes. Additionally, you get all these observability things and telemetry that Istio offers also for your host-based services for the cost of just installing a proxy. And this is how it essentially looks like. We do have a Kubernetes cluster running a service A, and a host-based cluster with hosts A and B, or more if you like, running an application A. And you see you just install the Envoy proxy, that's the technical proxy for the Istio service mesh, connected to the control plane, and everything can run on the mesh, even outside of the Kubernetes clusters.
So that's all nice and good. But now come the bad things. We had some security concerns with Istio. Istio control plane runs with quite some high privileges. As I mentioned in the beginning, for our Kubernetes clusters, multi-tenancy was a case. And so we, of course, use pod security policies. And we are quite strict about our security policies. We do not allow running containers as root. We do not allow writing into the uppermost container layer. You need to mount volumes for doing so. And we, of course, do not allow running privileged pods or mounting host ports. So a bunch of things is prohibited in our clusters on our own choice. And the control plane uses some quite high privileges, which is okay for the control plane, because the control plane is configured and deployed by us centrally anyway, so we can give the control plane higher privileges. Nevertheless, for some things where we could get around, we tried to change that, and we will try to do upstream pull requests as well for leveraging those things which are quite easy to leverage. But there were harder problems as well. The teams which want to use Istio, which deploy their applications with a sidecar configuration attached, they needed higher privileges than we wanted to allow. They needed the privileged attribute, they needed the net admin capabilities, because in Istio 1.0, to get your proxy transparently injected into your pod, Istio changes your IP tables definitions. And to change IP tables, you need privileged and net admin. And that was not really an option for us. For a proof of concept, for a prototype, that was fine. We provided dedicated namespaces with that higher privileges and allowed operators to do that there, but just for that proof of concept problem. The book info sample application of Istio, which showcases what Istio can do, had the same problems. That dummy application tried to use higher privileges. They wanted to run as root, which is absolutely not necessary for a dummy application. So we worked around that and changed their manifest to get that running as well, and we will provide them as upstream pull requests. Additionally, the sidecar injection made us a problem. How do you get your proxy into your applications? There are two mechanisms. Istio has a command line tool, Istio control, and with that you can inject or enhance your deployment manifest. The other option is you put a label on your namespace, and there's an active component within Kubernetes as an admission controller. It sees, hey, you have a new deployment, and then it enriches the created pods automatically within the cluster. So you don't need to do that with the command line interface. The Istio control option, when you do the enrichment, works quite fine, but the enrichment with the admission controller has an undefined order. And if you do pod security policies, then you have the problem that first, your pod security policy kicks in and wants to add defaults. At that point in time, the enrichment of your pod is not done yet. And afterwards, the validating pod security policy admission controller kicks in and says, hey, you have the wrong pod security policy attached. And you need to tune them quite finely to get that really working. And we did not succeed so far in doing that. So currently, we need to do Istio control for enhancing the sidecar, which for our setup is not so bad because, as you saw in the beginning, we have quite some standard deployment pipelines, how applications are deployed into the cluster anyway. So we can run the Istio control there, and no application operator needs to do that on his own. With mesh expansion, that's an interesting thing. With mesh expansion, we had some problems as well. Connecting a host-based instance to the control plane is doable, but with Istio 1.0, you need manual DNS tweaks with DNS mask on the legacy node. And you need to expose your Kubernetes DNS server to the outside world, which is not standard, at least. We did not manage to submit telemetry data and policies to the control plane because that's part of the envoy details. The envoy proxy on the legacy host gets configured from the Istio control plane, but that already assumes you can reach anything within the cluster. And it tries to submit telemetry data to your pod IP addresses, which I mentioned are in the CG-NAT space and not routable outside the Kubernetes clusters. And we needed additional tweaks to IP tables manually to get around that one. And for the inbound mesh expansion call, so you have a legacy node which wants to talk to a Kubernetes service in mesh, that we didn't get to run at all because of the same problem that the proxy would try to reach pod IP addresses directly. And MTLS, I don't want to talk about that one. That did not work at all in 1.0 for mesh expansion. So
this didn't work for us. The Istio 1.0 release just wasn't suitable for the setup we were running if we wanted to use mesh expansion. As you heard, there were many tweaks necessary to get it running. And on the expansion nodes, there was a lot of interference between everything. So we didn't get it running by no means anywhere near productive. So this sort of blocked the migration of a lot of services to Kubernetes. And many colleagues and teams are trying to move stuff of theirs into Kubernetes. So we needed an intermediate solution that was sort of available instantly. And so we set up something that looks a little bit like a service mesh, but with severely restricted functionality. Essentially, it just does the MTLS part. We used essentially for the client a Squid web proxy, and this was doing, or this is currently doing, the TLS unloading, including the client certificates. To help our users to get that running, we at least were able to implement automatic sidecar injection, so it's relatively simple to add that Squid proxy. On the server side, you see that we use an Apache for validating the client certificate and offloading the TLS. And this is essentially because many of our web services have an Apache in front of them anyways, so we can easily use that to do these steps.
And then, after we had that intermediate solution, then came Istio 1.1 to the rescue somehow. The control plane connection I managed for mesh expansion, that works with Istio 1.1 because they put the ingress gateway in a lot more central way. So everything which is expanded communicates with the control plane and everything within the cluster through the ingress gateways. So control plane connection worked. Telemetry data worked now. Outbound expansion, by that, works. We don't need any IP tables or DNS mask tweaks anymore. You need one line in your etc hosts file for one lookup of the name Istio pilot and Citadel, I think. You need them in your local etc host file with the IP address of the ingress gateway. And that's all you need besides an envoy proxy on your host-based installation for the outbound expansion. MTLS setup by that now worked. When looking with TCP dump into your connections from the cluster to your host-based world, fine, everything is protected. And then our security concerns with netadmin and privileged attribute. Istio introduced Istio CNI, which is obviously CNI plugin. You install that centrally on your cluster on every node. And there's a central component node with central higher privileges, which takes care of all the IP tables attributes. It's not in the context of the application pod anymore. And by that, it does not need the privileges of the application operator to do the IP tables operations. So that was fine from our perspective. So all good now? Now? No. Inbound expansion, we so far did not get running. That might well be our fault. It's not that we put too much effort so far into that. It is supposed to work. The documentation for 1.1 says, yes, inbound mesh expansion does work. We'll see. That's one to do. The automatic sidecar injection still has a problem with the order of pod security policy admission control and the enhancement of the sidecar. The documentation of Istio, same for generally Istio, is complex. Istio is complex. There are voices saying Istio is as complex as Kubernetes itself, which might well be true, at least if you go into debugging things and need to dive into the Envoy configuration and what Envoy does. Ideally, Envoy is a black box for you and you don't need to touch it. And partially the documentation was inconsistent. As with all documentation that will change over time, of course, there were some significant changes between 1.0 and 1.1, and of course it needs a bit until everything is consistent again. And another thing, we did not dive into how to configure your Istio services now, so how to configure your services to make use of Istio. But especially in a multi-tenancy context, that's still unclear. Which party of a cross-tenant communication is responsible for providing what part of configuration for an application? I did not find any real good practices so far, and we are on our way to provide some. But yeah, it's definitely not easy, and it's unclear for us and needs to be defined. And now it does not work anymore. There we are, some delay. Delay is something we cope with on a daily basis, right? So we need to solve some remaining issues. The inbound mesh expansion is still to be done. It's supposed to work. Currently, it does not. We need to evaluate large scale, of course, because we want to run it in large scale. We need to go into the production readiness, how to scale the components. Are the default settings good so far? Istio already defines horizontal pod autoscaling for the control plane components there where it would work, where it is scalable. And we need to find out if that really works for us. If the failovers when a component fails does work, so redundancy, we need to check that. We need to trim down the permissions. We use the default so far. Let's see if we can even remove some more permissions. Check the scalability, I mentioned that. The multi-tenancy questions are to be defined, the responsibilities, who does provide which configuration, who is allowed to change which configuration. You don't want to end up with a situation where one person wants to change which version of a service to connect, and that's changed for everybody. That would be not a good thing. And during KubeCon, or the weekend before KubeCon, there was a new post about performance overhead. That the Envoy introduces quite some latency, 8 to 16 milliseconds per request, and the costs, so that you need CPU cycles, obviously, and if you run that large scale, that sums up. Istio is already on the way to improve that, but we want to measure that in our context, of course, as well before applying that large scale. And we need to check if our services really can cope with the additional latency. Imagine you have a service with a 100 millisecond latency goal and you already are at 80, so it gets a bit tight with adding 16 milliseconds for Istio. We want to leverage more benefits of ServiceMesh. That's multi-cluster, so our front-end and back-end clusters, for example, shall be connected, or data center 1 and data center 2 shall be connected. Spiffy is a standard for secure identities, which is already supported in Istio. We want to dive in there more and integrate that more with our existing legacy world. Locality-based routing is an interesting new feature of Istio, so you can really control where to route your requests, so you can keep your requests in the same rack, for example, on the same switch, so they can optimize your network streams. Error scenarios are to be considered, and we want to go into authorization on a request basis with JWT. Istio 1.2 is released by now. Maybe that solves some of our concerns or some of our remaining questions. And of course, and I mentioned that we want to provide upstream patches for the things we found and changed for our setup so far. I mentioned alternatives. The most fitting alternatives in the Kubernetes context are Linkerd 2 and Console Connect. We had an eye on them. We did a feature comparison, again, with the help of our colleagues from Innovex. We did a matrix, hey, what are the features? And we talked with the Linkerd guys on KubeCon, for example, and it came out Linkerd does not support mesh expansion and multi-cluster so far, and mesh expansion is about 6 months out. So that's kind of a blocker for us when we really want to proceed with the topic. So that's one of the things why Linkerd 2 is ruled out. They have a better performance, it seems, from the metrics, and they claim they have a very simple setup. And setting up Istio is not simple, definitely. Maybe if you just use a public cloud provider and just press a button, yes, Istio enabled, that's easy. But we are doing bare metal and doing things the hard way. Console Connect, this we really evaluated because the feature matrix looks good. But yes, there is a but. We did that in a time box. And after investing like 3 or 4 days, we said, no, Console Connect is not an option for us. The expansion only works on a flat network, which we do not have with our CG NAT infrastructure. And if you want to do some sophisticated things, you really need to go into the Envoy configuration. You give Console Connect some Envoy snippets, and that they are injected into your Envoy configuration. And that's one thing we didn't want to go in there. So we dismissed Console Connect as well. So we will proceed with Istio, then 1.2, and our timeline for getting things really in production is Q3 of this year. So on the next conferences, we can report on how that really behaved in production and if the ideas and the fixes we found so far really solve our problems. A short summary, do you want?
Okay.
Let's go.
As you like. So you say that Istio 1.1, probably even better, Istio 1.2 will fit what we actually need. The feature set looks fine, a couple of configuration things still to be resolved, but nothing that looks like a blocker right now. Although it's quite an effort to get it set up right. The organizational questions will be solved, can be solved. Most of the things we can encapsulate in the continuous delivery pipelines anyway, even if the separation of concerns is not perfect in Istio. And overall, the direction of development of Istio is looking very promising, so that's the thing we'll stick with for the time being. And that's all we brought today. Thanks for your attention.
I think we finished just on point, so maybe we don't have time for questions. Is that right?
2 minutes?
Okay.
Great.
Who has questions? Otherwise, we will be here after the talk anyway, so you can come forward as well. There is one question. Do we have a microphone? Oh my God. Yes.
Whoever catches may ask a question.
How does test? Okay,
yes.
Great, thank you. Yeah, I'm wondering now that there's this Istio CNI plugin, what part of the sidecar injection still conflicts with your PSP?
It does not conflict anymore with Istio 1.1. So with 1.0, you had a sidecar and you had an init container, which tweaked the IP tables rules. The init container needed the netadmin privilege. And the init container is replaced by Istio CNI. So now you only have your Envoy sidecar, and that's fine. That doesn't need more privileges than your application itself.
Okay, why is there still a red cross inside of automatic sidecar injection? Or did I read it?
The automatic injection, that's when you label your namespace that for everything in there, the sidecar shall be injected. And that's the order of events with the pod security policy admission controller and the Istio injection admission controller, and then the validation afterwards. It gets rejected from the pod security policy validation because it afterwards changed its definitions.
Okay.
We can talk later if you want. Any other question? So then thank you for your attention and have fun on the final day of the Container Days.